In this example, you're being given not the original function, but the derivative function to start with. So we're starting with f prime of x here, which is important to notice. Some people move too fast and they think that, they automatically read it as the original function f of x, and that could end up taking you down the wrong path real fast. And then from there, they want to know on what intervals is the original function f increasing or decreasing. Well, anytime somebody wants to ask me where a function is increasing or decreasing, that is immediately telling me that I need to run a first derivative test. That's the identifier right there. So as soon as I see that language, I know that I'm running a first derivative test. The great news for us is that step one of the first derivative test is already done for us. They gave us our first derivative to work with. So we don't actually have to go find a derivative in this situation. Then step two of the first derivative test would be always to find your critical values. So critical values are going to occur in two places. Critical values occur when our derivative equals 0 or when our derivative is undefined. You really want to look out for that undefined situation. That's the one that most people forget about. That happens usually when you've got a fraction and you would end up in a division by 0 situation. And so what you can see on this problem is that is something we're going to have to be aware of because we've got a fraction, so we have to be concerned about where this would be giving us division by 0 because that would be undefined. So to do that, you just kind of pull out that bottom of the fraction and you're going to set that piece individually equal to 0 and solve that little algebra problem to see when this would be undefined. So first thing you would do to cancel out a fourth power, you would fourth root both sides. Then we would end up with 5 plus x cubed equals 0. And then from there, we would go ahead and move this over to the other side. We'd get minus 5, minus 5. We get x cubed equals negative 5. And then we would cube root both sides to cancel out that cubed. And we would end up with x equals the cube root of negative 5. So that is one of our critical values right there. Then we go back and we're going to deal with the top idea, which is when does this derivative equal 0? So you're going to go now and go back and kind of do the normal algebra that most everybody remembers this part. It's the undefined one that a lot of people forget. So we would get 0 equals, and we would have negative 3x over 5 plus x to the third to the fourth. So from here, the nice thing about this is the first thing you would do is you'd want to get that piece out of the bottom. And because there's a 0 on the other side, as soon as you multiplied both sides by what's on bottom, the 0 is going to just make whatever that is. 0 times anything is 0. And then we have negative 3x. And now we'll go ahead and divide by negative 3, divide by negative 3, and we end up with x equals 0. That's our other critical value. So once you've got your two critical values, now you go into step 3 of your process, which is where you're going to do the actual first derivative test. I'm just going to call it the first D test. This is just what I refer to as the number line game. So you would lay out your number line and you were going to mark your critical values on there. So we had a critical value at the cube root of negative 5. That's a critical value. That's a negative number. You can cube root negative numbers all day. When you cube a negative, you get out a negative. So that's a negative value over there. And then I would go ahead and plug in x equals 0. That is our other critical value right here. To do your first derivative test, you now need to kind of pick test values on either side of these things. So you'd want something outside over here, you'd want something in between, and you'd want something outside over here. The cube root of negative 5, you got to kind of be able to rationalize in your brain where this would live, right? So it's got a value of something, let's say, so if you knew the cube root of negative 8, that would end up being negative 2. That should be one we know. So we can kind of use that as a gauge. We'd know that negative 2 would be further out this way. And if I did the cube root of negative 1, that would be smaller than that. That would be negative 1. So negative 1's got to be right there. So that's how you kind of work with these roots when you don't have a calculator, like on this problem where this is a calculator not allowed section. And then out here I would put 1. So now that we've got our values, our test values, these are what we're going to test in our first derivative. Remember, it's a first derivative test. Math people are not creative namers. If it's called a first derivative test, it's because that's what you're doing. So we come here and we go to plug into this equation. So we do f prime of -2. We're going to need a value out for that. We want f prime of -1. We'll need a value there. And then we're going to want f prime of 1. So we plug into this equation. We get -3 times -2 over, and then 5 plus -2 to the third, and all of that to the fourth. You could do this all by hand, but really when we get down to it, all we care about are positives and negatives. So when you look at the top here, that is a positive number. A negative times a negative is going to give us a positive. And when you've got an even root on something, an even root, no matter what comes out of there, if I plug a negative into it, it's going to come out positive. If I plug something positive into it, it's going to come out positive. So we end up with a positive over a positive, which is going to give us a positive. So on this side, we know that this is going to be positive and therefore headed up and increasing. Plugging in -1 into my first derivative, I would get out of there -3 times -1 over 5 plus -1 to the third to the fourth. Again, same idea. You don't care about the actual number. You just care positive or negative. So we've got a negative and a negative on the top here. So that's going to be a positive. And then on the bottom here, again, anything to the fourth power is a positive, so that would be positive. And so that is also going to be positive and therefore increasing. And now we're going to plug in our last test value. We're going to go ahead and plug in 1. So we get -3 times 1 over 5 plus 1 to the third to the fourth. So then from there, at the top now, we've got a negative times a positive. That's going to give us a negative. And then on the bottom, we have, again, our positive, because anything to the fourth power, anything to an even power is always positive. So a negative divided by a positive, when the signs are different, it's going to be negative. So this would be negative and therefore decreasing. So going back and reminding ourselves what they wanted, we're looking for where this is this is decreasing. So we can see that this is going to be decreasing, starting at our critical value of 0 here, and then heading off this way forever because it's not going to ever stop decreasing. So we'd be looking at an interval that goes from 0 and heads to infinity. That's where our graph is decreasing, and that would be option C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.